Awesome. Hello again. So now I'm going to be churning through a bunch of stuff. I need goofy legs in. Okay. But photons. Okay, so photons. I'm going to look at photons a couple of different ways. Photons. So every photon is both a positive part, positive part and a negative part. As far as I'm concerned, this would be inflow, divergence, and this part convergence. When I do the next diagram, it'll make that more obvious, but this is about the wavelength thing. So here's a super high energy photon, right? Because this photon, the entire photon, only takes up 2 Plancks. Well, actually, like 1, 2, 3, 4. So that's a 4 pi Planck. Because if it was a 2 pi Planck photon, it would be in orbit around itself, and it would be a piece of matter. So this is not quite a piece of matter yet. It's just a ridic high frequency photon, right? Because it only takes up 2. And if this one takes up 6, that's a lower frequency photon, right? But when you do it just like this, this doesn't really represent the energy, right? Because this is supposed to be a higher energy than this one. And you do it by the wavelength, but what if every photon had exactly the same number of Plancks to it? Okay, what if? And I suggest, well, hey, that might be true, because they're each supposed to be single quantums of energy, right? So let's imagine, shoot, where's this permanent? Okay, so let's imagine, just for the sake of this diagram, that every single photon has 8 Plancks involved at 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. See, as you string out, your wavelength becomes longer. More on the energy spectrum, less on the time spectrum. Less on the energy spectrum, more on the time spectrum. Less on the energy spectrum, more on the time spectrum. But every photon would have exactly the same number of Plancks involved in it, because there's a certain number of Plancks involved in a single quantum of energy. And all photons have the same total energy. Some of it's more expressed in time, and some of it's more expressed in voltage. This relates to that previous video I did about the time distance being inversely proportional to energy. Distance inversely proportional to energy. I think this is a universal thing. in my cosmology, everything is just made out of space. Space has an innate energy density. When we add energy, what we're doing is densifying space at the same time. They're one and the same thing. When you densify it so much, then it becomes trapped over itself. A 2 pi photon will become matter. 2 pi Planck photon will become matter. What was the other thing? Oh yes, the other idea of photons. Okay, so another way of looking at photons, a fluid model, would be, here's your nucleus. And we'll just use a spherical electron orbital because that's going to be easiest way. So there's our electron. And let's say this is S2 orbital, right? S2 orbital. But then it drops down to the S1 orbital. Okay, so let's imagine the universe is full of this fluid, an etheric fluid. I don't want to say ether because they get all touchy about that. But if the universe is singular, then a constriction in one place means another part must have been stretched out. All of these things compensate. It's not like there's just space and matter floats in space. Matter is made out of space. When you make a piece of matter, you took a bunch of space and put it in a little tiny distance because of energy, per previous video. Okay, so we had our S2 orbital, shrinks down to an S1 orbital. This goes like this. All the fluid falls in at the speed of light because it's a really runny liquid. Okay, all the fluid falls in at the speed of light. Now, that creates in the fluid around this wave where this fluid that used to be resting here has now had to move into here. That creates a vacuum here, a low density area here that gets sucked in till it merges to the density it's supposed to be. Oh, but then there's this, now that ripple of low density reaches out. Okay, the external portion is low density, divergence, electron. Because this is the outward side of an ever-expanding surface. So this is always going to be bigger than that just was. Therefore, this is lower pressure than that just was. The inside layer, on the other hand, is these two arrows are further apart than they were a second ago. These two arrows are closer together than those two arrows, so this is relatively positive, this is negative. There we go. It's a wavefront, an expanding, ripply wavefront of pressure, essentially. This is divergence, this is convergence, working in unison, almost like a toroidal thing. Divergence, convergence. For every divergence, there is a convergence. Ripple expanding in space. Okay? Entanglement is simply if you have a pair and these are out of phase with each other, then, oh, and the singularity is that anything you do to here, you did to here because this is one membrane. This is a circular motion. This is like a singular surface. It's not a bunch of parts. If there are parts, they're intimately connected, like directly connected, so they might as well be a whole. Okay, this is divergency. This is convergency. It's a ripple. It's a bubble. It's just like an expanding bubble that expands at sea. You can interrupt it at any place. What we detect is this expansion part and contraction part, the divergence and convergence. When we burst the bubble. But that pressure zone is a spherical bubble. The entire probability sphere of a photon is the photon. It's just when we collapse the photon is when we destroy that wavefront. That wavefront moving at the speed of light. We'll say it's expanding, but I'll have to imagine that it's just constantly expanding. We're zooming out at the same speed it's expanding, so we can't tell, so it looks like it's just exactly the same size, right? Or expanding slightly. Now it comes, this was the atom, there's the electron field. This is the photon expanding out. Here's another atom, right? And here is, let's give this wave front, the thickness of this membrane is the wavelength, that one? Okay, the thickness of the membrane is the wavelength. The thickness of the membrane is the wavelength. So, you have an atom that happens to have electron in an orbital where the resonant cavity gap here is exactly the same as this wavelength. So when this wave hits there, something about superfluids, no doubt, that I haven't researched yet, all the energy would go into there. All of the energy, the entire wave front energy, when it resonates, slips in sideways, because really these are sideways motions. This is like sideways in both directions. Outwards, this is sideways in both directions. Inwards, simultaneously. Weird dimension things, but hey. Okay? It gets trapped inside. It's just resonant pings back and forth from these resonant chambers. This drops down. It's like the bell got rung. Sends a ripple over here. Fits perfectly inside this resonant chamber. So that boosts this energy and makes it larger, and now it has a different resonant frequency because it's a larger chamber. This is kind of how I see photons. Just saying. But do the math. I dare you to do the math on the 2 pi Planck length photon. Okay, you look up the energy for this photon, right? Whatever the energy is, I have it written down someplace else. The energy of this photon, if you convert that energy into mass, and then you find out the Schwarzschild radius of that mass, you will find out that this energy creates a mass that has a Schwarzschild radius of this. Mass is a photon trapped over its own gravity. Mass is equal to energy over energy distributed over a spherical surface moving at the speed of light rotating at the speed of light, moving at the speed of light, but in orbit, therefore acquiring angular momentum c squared, which is essentially the same as inertia. Okay, angular momentum distributed over a spherical surface is inertia in all directions. This is how we get it. Mass is energy in orbit over a Planck, getting angular momentum, getting inertia. Yeah, I don't know. Or maybe I'm just crazy.